the fact that it's an even function. What are you doing, Alyssa?
So how do you do the front part?
So you keep whatever is in front of the x there, and you drop the power down in front and multiply by it. So what's 3 times 2/3? Multiply the top, just the top. So it'll be 6 on 3, and what's that?
What's that equal to?
Just the number. I'll do it up here, Clarice. So when we're finding the derivative, we take that power of 3, drop it down in front. So 2 times 3, take 1 from the power, and then the 5 disappears. So that gives us 2/3 of 3 is just you times 3 times the 2, and that gives us 6 on 3. 6 divided by 3 is 2. So just 2x squared plus 6x minus 8. You don't. Shouldn't be negative. Check because your AC, C is negative, so it should end up being plus. It should be b squared, and then you're doing minus 4AC. But because C is a negative number, it will become positive. The original rule, yes. But then because one of the numbers you're multiplying by is a negative, ignore the take for a second, your answer overall will be negative, and they become a plus. Once I have my derivative, guys, what do I need to look for to find any turning points? Once I have my derivative, what do I look for? What do I know about derivatives? It's let me find turning points. Yeah, turning points happen when the derivative is equal to 0. So set f dash of x equals 0. So we have 0 equals 2x squared plus 6x minus 8. Now, like I said, guys, we've got 2 ways to solve these ones. You could go straight from here into quadratic formula, and that would give you the right answer. But there are easier ways to do it. And the easier way would be to recognize that this isn't monic, but it has a factor of 2 in front of it. And everything else is a factor of 2 as well. 6 is even, 8 is even. So we just divide the entire equation by 2. So divide the left-hand side by 2, and divide the right-hand side by 2.
Sick of that. Doing that every time. Right, divide by 2 instead of just doing. Is that just annoying? I feel like having to write it on both sides just to show the
I think
you've done when you've done.
yes, but it doesn't annoy me, no. I do. If I was solving this question, I wouldn't be writing it down. If I was solving it for a solution set or something, I'd just be steamrolling through. But the other thing is, if I don't write that, people that haven't been keeping up with what I'm saying will look at that and be like, wait, where did everything go? How did it change between those 2 lines? So I try and be as clear as I can. And, you guys should as well be as clear as you can with your thinking so that someone can just look at it and be like, oh, that's the answer. So you should get 0 equals x squared plus 3x minus 4. That's a monic. I can factorize that pretty easily. So 0 equals x plus or minus something, x plus or minus something. So I need 2 numbers that add to positive 3, multiply to negative 4. The only numbers that multiply to negative 4 would be 1 and 4 or 2 and 2. The only way that they could become a -4 is if it's a -1 and a +4, because then those ones add to +3. So -1 plus 4. What x values does that give me as my possible solutions?
1 and -4. They flipped.
They're flipped, so it'll be +1 and -4. So x equals 1 and -4. I'll do the quadratic formula way. Yep. So if you were doing the quadratic formula, you could do it from that line. So a equals 2, b equals 6, and c equals -8. Also, fun fact, if you did see that they had a common factor, you are more than allowed to divide it. Like, you could also do it from the next line down, where a would be 1, b would be 3, c would be -4, and you would get the same answer. But let's do this. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. Negative b is -6 plus or minus the square root of 6 squared minus 4 times 2 times -8 over 2 times 2. So that's -6 plus or minus the square root of 36. Now, I'm just going to go straight to putting a plus in there because we've got minusing a negative. 4 times 2 is 8. 8 times 8 is 64 over 4. -6 plus or minus 64 plus 36 is 100. 6 plus 64 is 70, plus 30 is 100. So, and what's the square root of 100? 10. So this equals -6 plus 10 over 4, -6 minus 10 over 4. -6 plus 10 is 4 over 4, which is 1. -6 minus 10 is -16 over 4, which is -4. So we did get to the same answer. Obviously, the left-hand side was quicker. But do remember, the left-hand side doesn't work all the time. Sometimes you have to use the right-hand side. Now, to link this with what we're going to do today, guys, I now know that at x equals 1 and x equals -4, I have turning points. Can you tell me anything else about those points aside from the fact that it's a turning point?
They stop.
There's no rate of change at those points. The rate of change is 0. Do I know if they're minimums or maximums, for instance? Because these are the x values. Like, I could have, this could be if this is my Cartesian plane, I could have because remember let's say that's -4. It's 1. You see that's a minimum point. That's a maximum point. So it doesn't have anything to do with the positive or negative sign of the 4. What we're going to learn about today is how to determine whether they are a minimum or a maximum based on what's happening around them. Can anyone think of another way, though, that we could figure out if it's a minimum or maximum?
Which would x, can you find the y value or subbing?
Yeah. If you sub in the y value, you will get, you'll be able to see which one's taller than the other, and the taller has to be taller than the higher value has to be higher than the minimum value. But that only works because we have 2. If we only had one answer, there'd be no way then to know if it's a maximum or a minimum. So that's what we're going to look at today. Are there any questions on that before we get on to the lesson for today, guys? Are we feeling all right with following that process, finding our x values?
Yeah, something.
I did say find the turning points. We probably should sub it in, but I want to get started on the stuff, so The reason I kind of don't want to do it is because it has that 2/3 in there. It's going to be like a fraction in your answer, and I just don't feel like dealing with that at this moment in time. Okay. So, guys, real life application of stationary points is in the field of optimization. So that's what I was talking about yesterday. Like, you want to figure out how much food is the perfect amount of food to feed your fish, to make sure they grow nice and big. Or you might want to see how long is it worth paying my staff overtime? Am I making more money by having my staff work longer, even though I have to pay them extra money to work that time? So you may only be making an extra $2 an hour if you're getting extra staff to work, so it may not be worth the extra money. What I'm getting at there is we need to know whether we're talking about a minimum or a maximum, because when we find a stationary point by setting it equal to 0, all we know is that it is a stationary point. And there's two types that we've seen. We've got maximums, we have minimums. There's actually a third type of point. We're not going to deal with it next year. We'll look at it next year. And it's point of inflection. And it looks kind of like that. And it's where, like, can you see that before that point, the slope is positive? And then it sorry, I've drawn really badly. See that, like, going up to it, it's positive, then it levels out, and then it becomes positive again. So that's another type of stationary point as well. And if you're trying to find a maximum and you've actually found a point of inflection, you don't want to stop there. You want to keep going up this way. So to classify the type of stationary point, we look at the derivative of the function, and then we look at it on either side as well. So guys, if I have a maximum, here it is. This is my function. This is f of x. Sorry, I shouldn't put the dash there, because this is f of x. Here's my stationary point, so that's where f dash of x equals 0. Before that, can you see that at every point to the left of that point, my slope is positive? Every point after it, negative. So if you have a point, and if I was then to do my plot my derivative function, it'd look something like this. Positive, 0, negative. So this is the f dash of x. Up until that stationary point, the slope is positive. The slope is getting lower though, so it's approaching 0, gets to 0, then the slope is negative after that point. So a way we can figure out if our slope is a maximum, you just check the derivative a little bit to the left of it and a little bit to the right of it. If it's positive before it, negative after it, it's going to be a maximum. Because a maximum, you're going up to it, and then you're going down after it. Did what I just say, like, make no sense based on Alyssa's face? Okay. Apologies to people watching the recording, because I'm going to do this on the board. I'll do it over here, guys, just so we can use the grid. Let's say this is my function, right? You see it approximately there is my turning point. Of course. So I know the derivative at that point. I'll use a different color for the derivative. 0. Is 0. Now, before this point, the slope of my function is going up. So my derivative function will have will be in the positives to the left of it. After the turning point, the slope of the function is going down. So my derivative function, because a downward slope is a negative derivative, my rate of change is negative, will be in the negatives. So what I'm saying is, if I don't know my original function, what it looks like if I just gave you here's a function, find the derivative, solve it, what we're doing at the moment is we're finding that dot. But what I'm saying is, if you look to the left of it, you look to the right of it, you're going to know whether it's a maximum or a minimum. That's all we're sort of doing today. So if you have a look here, if it's going up and then it's 0 and then it's negative, sorry, if it's positive, then it's 0, then it's negative, that means you're looking at a maximum point. If we look at a minimum point, can you see that we have 0 down the bottom, the turning point of where the derivative is equal to 0? Before that, is our slope positive or negative? It's the slope to negative. And then after it, it's positive. So if we look at the turning point and we look slightly either side of it, if to the left of it it's negative and to the right of it it's positive, that means it has to be a minimum point because the slope before the turning point was going down and after the turning point it started going back up again. That's all we're doing. We know what's happening based on what's happening either side now of our turning point. Yeah, so what we do basically is let's say that f dash of x equals 0 when x equals 3, right? What you do is you just go, okay, well, let's find f dash of x. Sorry, we write it like this normally. Let's find it at 2, let's find it at 3, and let's find it at 4. Now, we already know what it is at 3, it's 0. Now, you either in your head or in the calculator or solve it. And let's say that f dash of 2 was a positive number. I don't even care about what the number is. I just need to look at whether it's positive or negative. If it's positive, and then I look at f dash of 4 as negative, I know that my slope is going up, then it stops, then it goes down. What kind of turning point is that? It's a maximum. Does that make sense, guys? Yeah, and if it was the other way around, it was negative, and then it flattens out, and then it goes up, it must be a minimum. Are these points of inflection? It is possible there'll be a question in the textbook that is a point of inflection. We don't see them. We don't deal with them in year 11, really. I won't expect you to be talking about points of inflection and what they happen. Basically, they only happen in cubics and functions like that. You don't see them too often in lower order functions. Okay. So the way you know that you're being asked to say whether it's a minimum or a maximum, guys, is the question will say something about classify. So you can see that it says classify the stationary points. What that means is it wants to know where the stationary point is and it wants to know what it is. So we've got to say this stationary point is at 0.5 and it's a maximum, or this stationary point's at 2.7, it's a minimum, whatever that is. Okay. So guys, once again, I prefer to work in fx rather than y for these ones. F of x. So oh, you're thinking about the sine cos tan stuff where it has d at the end? Maybe? Oh, yeah. So instead of saying f of x and then f dash of x, you could say dy dx if you wanted to. As well.
Delta y over delta x have f of x, like f dash of x, y dash.
Yeah, all three. So we could have y. We could also have f of x. And then when we differentiate it, we could say the f dash of x. And that's the same thing as delta y over delta x, which you can also write as capital delta y over capital delta x. Or you could also write it as lowercase delta y over lowercase delta x. Or you could write it as y dash. Out of all of those options, I prefer f dash of x. I'm going to continue with that on the next line. So differentiate 3x cubed, guys. What would we get? 9x squared. Negative 8x. And then plus 6. What's our next step? Exactly the same as before. There's just one extra step where we classify. make it set it equal to 0. So set f dash of x equal to 0. Guys, you'll notice I keep writing this every problem we do. The reason why is particularly in your externals, they often have a mark associated with like making a statement about things like this. So, and the other thing as well is, a lot of students will do this. They'll say like, okay, f dash of x equals, I don't know, 5x plus 3. Then on the next one, 0 equals 5x plus 3. If you haven't said why you're subbing in a value, it's actually not, it's like really bad practice. You're supposed to say set fx equal to 0 to find turning point. I cut off the to find the turning point because it's sort of implied, but it's really lazy to go from one line to the next and change something without saying why. You're allowed to do it algebraically because you're saying what you're changing as you go, and each side of the equation stays the same overall. But you really need to be making sure that you're explaining why you're making the changes that you.
So what do you do when you've got x squared and you've got x? Or you just
We're going to have to quadratic formula this or use our graphics calculators. I'm going to probably use graphics calculators on this one. Because it's non-monic, no. So we end up with 0 equals 9x squared minus 8x plus 6. So yeah, I think we're going to have to graphics calculator this one. You could use quadratic formula. Just looking at that though, it's going to be big numbers like 4ac, 4 times 9 times 6. That's just a big number. I don't want to do that in my head. This one just isn't in the tech-free realm. Actually, I have my graphics calculator up here. So, have I shown you that I got a new my app's back? It's very exciting. It is different. I don't like it as much as the old one, but them's the breaks. This is a lot more difficult than it looks. Okay, let's go to our y equals 2 menu. You guys will have to tell me what the rule was because I can't see it at the moment. 9x squared, take 8x, x plus 6. And then what do we put as our y2 line? Just 0, yeah. 0. And if I go to my window, I just make sure my thing's set out. I might go from negative 10 to 10 in each direction just because I was doing some other stuff on here and my window's a bit funky at the moment. Now if I graph that, well, that's an issue, isn't it? Are there any solutions? Well, that is not our function. That's the derivative function, remember? So if the derivative function is never equal to 0, what does that mean? How many turning points are there? None. There's no turning points in this function. It's literally just a line that goes forever. Well, I'll pop this in as my y3 just so you guys can see. So 3x cubed minus 4x squared
plus
6x plus 3. So let's have a look at in our graph. Can you see that there's no turning points? It just goes and goes up forever. So if we pop back to here, so give this a second. The way we'd say this, and you do come across these every now and then, is that there's no turning point. So I will admit I meant there to be a turning point for this one. When I wrote it, I obviously messed up here. Yeah, we'll do another one of these. My recording doesn't like me to swap in and out of OneNote. It always does this when I do that. We'll just pause this to. Sorry, I forgot to turn my recording back on once I fix the screen. So yeah, we just write that to finish off that question. And let's have a go at this one now. So this one should have turning points. Let's differentiate it, guys, to find our derivative function. So derivative of 9x squared. What happens to plus 18? Go on. What happens to minus 27x? And then what happens to minus x cubed? Minus 3x squared. Now, this is personal preference, guys, but this is what I prefer. I like to have my x go down in order of x's, if that makes sense. So x cubed, x squared, x, no x. So I'm just going to rearrange this so that the x cubes are at the front. You don't have to. If you're comfortable with it the way it is, you're allowed to do it that way. But just in terms of my own preferences, I like to have my x's at the front and my constants at the back. Just make sure if you do rearrange it, the negatives stay with the number they're attached to. So that negative is attached to the 27, that negative is attached to the 3x squared. So they just got to travel with them. So next step, set f dash of x to 0. Question, Izzy? Equals 0. So 0 equals minus 3x squared plus 18x minus 27. Okay, guys, first question. Can we simplify this? Yes. How could we simplify that? Common factor of 3. Now, I'm going to do something even trickier. Can you see that 2 of my numbers are negative? It's better to have less negatives. So I'm going to factorize by negative 3. So that means the negative in front of 3 and 27 will disappear, but it'll put a negative in front of the middle x term. So I'm going to divide this side by negative 3. I'm going to divide this side by negative 3. 0 equals x squared minus 6x plus 9. Now, this looks like we should be able to factorize it, hopefully. Can I think of two numbers that multiply to positive 9? Add to negative 6. What are the numbers that multiply to make 9? Negative 3 and? Yeah, negative 3 squared. So 0 equals x minus 3, x minus 3. So what are my possible solutions for x?
That's just 3.
Just positive 3 is the only answer. So x equals positive 3.
Okay. So that means you got a turning point of 3.
Now, because of the numbers I've used, I've used like 27s and 18s and stuff because we're using that rule. We're going to do this one tech as well. So I am going to classify the turning point at x equals 3. Like I said, guys, the way we do this is we just sub x equals 3 into the derivative. So we know that f dash of 3 is 0. Now, we've already solved that 3 is 0. We just need to do the other sides. Now, yeah, that's what I want to talk about. Because there's only one turning point. that means my function either goes like this or like that. And that's how it continues on forever. So we can choose any number either side of it. So you can do 2 and 4, and those will work well because they're nice round numbers. If you, however, chose, if there's 2 turning points, and especially if they're close together, you need to make sure that you're going just either side of the point. So some people like to go like, well, I'll make this one 2.9 and this one 3.1, like go just like 0.1 either side of it. Because there's only one turning point, we are fine to go one either side of it. That's not an issue. So we're going to go 2 and 4. Now, you will hopefully be happy to know there is an easy way to do this. Does anyone know what the easy way to do this might be? Use your table. That's right. So if we go to our graphics calculator, guys, go into our y equals 2. I'm just going to clear this last question away. And I'll just put my derivative function into my y equals 2. Can someone just read out the derivative function to me because I can't see it on my screen? The derivative function. Negative 3x squared plus 18x. And what was it after the 18x? Minus 27. Yep, happy with that. So to set up our window, guys, just go our table. Second table set. Mine's starting at 0, going up in ones. I want it to start at 2 because our values start at 2. Then we just go second table. So we can see that at 3, we've got 0, which is what we expected. Before 3, we have a negative number. And after 3, we have a negative number for the gradient. So what that means is I have negative over here, negative. So that means my slope is falling, it levels out, and then it falls again. What type of function is that? Or what type of turning point, rather? Yeah, the point of inflection. Yeah, so it's a point of inflection falling. Therefore, at f of 3, there is a point of inflection falling. And generally speaking, guys, if you ever have a cubic where there's only one turning point, it will be a point of inflection. I'll just show you why. A cubic function normally looks like that. So you can see that it starts rising and it ends rising. Point of inflection is basically a cubic where these 2 points just come closer and closer and closer together, so you eventually get. So you can see they're actually quite similar, they just don't have that bumpiness in the middle. So that's why if you ever have a cubic with only one turning point, it will be a point of inflection. Is there anything we've forgotten to do, guys? Sorry? We've determined what type of it is. Have we given all the information about the turning point? There's something we've forgotten to do.
Turning point equals y value.
Yeah, we need to know the y value of the turning point, that's all.
Y1 equals, you did, negative 3x squared plus 18x, take 27.
Yep.
What do you get your positive negatives from?
So I set my table to start at 2 and go up in ones, and then I went second graph. See how it's got blue table above the graph button?
Start at 2 on ones. So
Yep.
second.
So you can see that at 2, my answer is negative 3.
The matter didn't regular. Oh, just negative 7. Yeah, that's good. 3, it should be 0. X equals 3, what?
It's because you've done a negative 27, not minus 27. If your calculator breaks out, it's minus 7. So now it's going to be negative value 0.
Yeah, yeah. I was very confused.
Yeah, it gets me sometimes that I forget about, like, I'll sometimes use a minus instead of a negative. I'm like doing like negative 3 squared or something, and it'll throw up calculator error. And just like, hmm. So the only thing we've got to do, guys, is just figure out what f of 3 is. So what was my original function? Plus 18 minus 27. Negative 9. So f of x equals negative 9. So okay. Let me just pull. What did I do last time to fix my screen not working? I don't even remember. Sorry. Yeah, I thought that's what I did. Yeah, put that recording back on and sub x equals 3 into f of x to solve for y value in t p. And I just did this on the calculator before, so I'm not going to write out the full working out, but f of 3 equals, I'll just, yeah, negative 9. 15 minus 27x, sorry, 3. So therefore, that's part of it. Also, a really common habit of, let's say this was negative 3, people will not put the brackets and they'll be like minus negative 3, and they'll be like, oh, well, that's, and then they'll do cubed and they'll put that into their calculator and they will get the wrong answer. So by putting the brackets in, it just helps you keep everything attached where it should be. But the other side of it is that it's clear what's being put in where. So therefore, there's a point of inflection, 3 comma negative 9. The next problem we're going to do, guys, is a practical one. So we'll see where this kind of stuff gets used in real life. Tell you what. Do we need this up there anymore, guys? Or are we good to keep on rolling? Right. So Pajingo Mine produces X tons of gold per month, with costs modeled by the function costs based on X is 2000 minus 75x minus 5x squared plus x cubed on 3, where C is the cost in dollars, and obviously X is the tons of gold they get per month. Have we started again today, Alyssa? Say fizzle sticks. Let's calculate how many tons they should mine so that costs are minimized. So straight away, what are we looking for? What do we want to find? Or theoretically, they can just mine an infinite amount. We're not going to focus on profits here. All we want is the production level for which costs are minimized. So this function only covers costs, right? So this function here is costs. We want to find the minimum value of this function. So what we want to do is solve for the x that minimizes monthly costs. So in other words, if there's two turning points, we want the minimum, and that's where the cost will be minimized. So if we put that function into the calculator, I think it'll look something like this. So we want to find, so basically where X is how much gold is mined, and this is how much it's cost them to mine that gold. Now, obviously, if you've mined this much gold, it's actually cheaper to mine even more that month. So you want to be mining this much gold because you're making a ton of money, but your costs are quite low. So you want to be finding the minimum cost for this. It's our goal. So to do that, we're just going to do the same process we've been doing. Find the turning points, find which one's a minimum, and all it asks us is the production level. So we don't even need to find what the cost is. We just need to know the production level, so what the X value is. So how many tons do we want to mine so that we minimize costs? Let's do it. So we have our function cost of X equals 2000 minus 75X minus 5X squared plus X cubed on 3. And we want to differentiate this. So we want to find the change in cost. So remember, the derivative function will tell us at what rate our costs are changing. And if we find the rates where the costs are changing 0, that's where our turning points are, and we can figure out which is a minimum. Questions so far, guys? Make sense? So I'll just show you over on the side, guys. X cubed on 3 is the same thing as 1/3 X cubed. And then when you differentiate it, the 3 just comes down. 3 times 1/3 is 1. So what happens to my 2000? Come on, skis. It's negative 75x. Negative 75 minus 5x squared. X. And then the plus x cubed on 3. That would become 3x squared on 3. So that's a 2. Doesn't look like a 2, but it's a 2 and 3. And that just becomes x squared. And I'm going to once again rearrange. Question? Yeah, so 3x squared over 3. The 3's cancel. We just left x squared. There's 2 ways we can solve this. Believe it or not, this is actually solvable tech-free. Because do we have a monic there? Yeah. Yeah, it's monic. We need to find two numbers that multiply to 75, add to negative 10, and... Sorry? It didn't have an x, so it gets dropped when we differentiate. 75 could be 1 and 75, 3 and 25, 5 and 15. And looking at that, we can get to negative 10 from 5 and 15. Positive 5, negative 15. So, we haven't even done that step yet. So, set C dash. I'm so used to doing Fs. Equals 0. So 0 equals x squared minus 10x minus 75. 0 equals, and it would be x plus 5, x minus 15. So therefore x equals negative 15. So I'll just give you a sec to catch up.
You do the same thing, so we go negative 4,
So we'll test.
6, and 14 and 16.
Yeah, we can make this one easier on ourselves, though. One of those answers is impossible. Which one? One of those answers is impossible. Negative 5. Can you mine negative 5 tons of gold? So because it's negative, it's not possible. So we can straight away make a note. X is tons of gold mined. You can't mine negative tons of gold. You can mine 0, but you can't go into the negatives unless you're actually yeah, you're just getting those generally mining companies aren't in the business of putting gold back into the ground. Generally speaking, there might be some weird ones out there that I don't know about. So as X is gold mined, negative is not possible.
So what's the color into this?
I don't know what's sadder, the person who put the gum there, the person who coloured in the gum there, or the person that just spent 5 minutes looking at the gum there. And I want to say it's the second person, but I think the third person is close behind. Okay, so we're just going to test 15, guys, now. So we're just going to test the nature of turning point at x equals 15. So we're going to find the cost at, now, how far either side do we want to go here, guys? Do we want to go like 0.1? Do we want to go 1? Do we want to go 10? It's up to you guys. 1 should be fine for this one. So let's go at... if you had like a turning point at 1 and another one at like 1.5, you might only go 0.1 either side. Yeah. These kind of questions, unless they're very simple, will be tech active. Like we obviously solved that tech free just because I looked at that and I knew that to factorize that, it'd take me less time than it would to like put it into the calculator and find the intersects and stuff. You definitely could have done that bit tech active. I just figured it would be quicker doing it this way. So let's do C at 14, C dash of 14, C dash of 15, and C dash at 16. Yeah, 15 is 0 because we've already got there. So we've just got to put that into our graphics calculators. So once again, guys, I'll get you to call it out to me.
-75 take 10x plus 3x squared.
Take 10x. What was after 10x?
10x plus
X squared. Whoa, what have I done? Probably should have deleted everything that was here before I started. Okay. 75 minus 10x plus x squared. And we just want to go to our table. Now, if you look at my table, guys, I didn't set it up. So I'm starting at 2, but what number do we want? 14. Now, I could go and change it, but because we're already going up in whole numbers, you can just arrow down until you get to what you want. So we have negative beforehand, then 0, positive after. So negative, positive. So we have flat at the point, it's going down, then it's going up. Nature of that point?
Next.
Going down, then it flattens out, then it goes back up. That's a minimum. So therefore, the costs of the mine are minimized when x equals 15 tons of gold. Have we answered the question? Calculate the production level for which costs are minimized. It hasn't asked us to calculate the cost, it just said the production level. Production level is X. If it asked us to calculate the cost of minimal production, we have to do that, but we don't need to find Y because it hasn't asked us to. If it said find the minimum turning point, yeah, once again, we'd have to find Y, but no, we're good. Questions about that one, guys?